Hi, so my name is Catherine. I'm a data scientist. So my talk today is about addressing bias in artificial intelligence. I've been a data scientist before the word was a thing. I have a background in applied mathematics and statistics. My first job as a hedge fund in New York City. I've worked for large companies such as Siemens, Sky, and IBM. I've held titles such as senior data engineer, lead data scientist, head of data, and I'm currently head of data science at Raincoat, which is a parametric insurance company protecting farmers in South America from climate change disasters. So prior to that, I was CTO director at GoBubble, which is an AI content moderation company. I filed a patent to do social media content moderation, mostly for football clubs. This talk is derived from a talk I made for a research conference, so it may be a little bit too detailed in places, and I will skip slides when I see anyone yawn, because otherwise I won't be able to keep it to 20 minutes. I'm trying to talk you out of getting into AI, no, just kidding. I'm trying to get you to, I would like to highlight some of the things I've learned across 15 years in the industry that I did not like, so this is more of a sort of rant here. But to start with the legitimacy of AI, is AI justified in all use cases? So there's three problems I would like to highlight, and one of them is when you have a student who takes a standardized test, she gets a perfect score, and then she finds out it was graded by a computer. It's something to think about. How does the extensive use of AI impact our creativity as human beings? And another one is a defendant who finds that a criminal risk prediction system categorized him as high risk for failure to appear in court based on his metrics. It's very common in the United States. And he had every intention of appearing in court, but data has already decided for him. Another one is the automated system, like the one I've built that locks out social media users for violating a platform policy and acceptable behavior. Users insist they did nothing wrong, but there is absolutely no policy to appeal. So these are some of the problems that we find, and we should ask ourselves why we're actually using AI and not humans for these problems. And there's a brief history of natural language processing that I would like to go into. I've got a background in transformers. My patent is based on transformer architecture. So it's a little bit more NLP based here. And so I will skip over this fairly quickly. But basically the idea of using a bag of words or a one-hot encoded matrix to represent text is actually as old as 1954. And we've only evolved from this in 2013, so fairly recently, which is why AI has taken off in the way it has. So natural language processing wasn't a field that a lot of people were interested in until also 6 months ago. But so yeah, the reason that is, and I hope I can make this a little bit more easy to understand, is that we used to represent text as a huge matrix of zeros and ones. So we would train it on some text, and then if the word is in the text, then it's a 1, and if it's not, it's a 0. Now these things get incredibly large when you train a model on the web or a very large text base. And what happened in 2013 is we started using representational vector, and we used vector embedding space. And Bauman, no, not when he was the blue guy, what's the man's name? Oh, Mikolov, yeah, from Google. So he started with the positional vector embedding. So his idea, and Google's idea, was to represent the words in a text as vectors. And amazingly, you can do very simple arithmetic with this. So for example, this is a famous example of the king, and if you deduct the vector for man and add the woman, you come up with the vector for queen. So AI can understand text and concepts because it has this multi-dimensional space where different words are close to each other if they are related, and you can also map countries to capitals, etc. So this is how we got to this point that we can actually even ask AI things that technically only humans should be able to understand. But this vector embedding space is really amazing, and there is a lot of quotes to white papers here. If you are interested, I can share this presentation at the end, but I won't get into too much detail on how we got here because I have too much to rant about. How do we evaluate language models? Before we send a model into production, we'd like to understand how does it perform, and all the data scientists will tell you, yeah, I've got this 98% accuracy and stuff. So Sam Bauman is the guy from New York University who invented Glue, and when it first came out, AI was scoring less than 70% compared to human performance. Now that changed in 2019, where they reached 80%. Now AI is beating humans on these benchmarks, including the super glue. However, the inventor of Glue said himself that time and again models ace their tests, deployment or when probed carefully. They fall apart in embarrassing ways pretty easily. So why do they fall apart in deployment? I've moderated social media traffic. I've been looking after fairly notable football clubs, and I had to make sure that there's no toxicity on their fan pages. So I encountered quite a few problems when I had this like 99% accuracy on my models when I first deployed them, and then people start posting stuff like fucking goal, and you're shouting and you're using capital letters, and your toxicity classifier thinks that this is a really toxic word. But it's not. However, if you say fucking fool, it actually is. So it's a little complicated for models to understand these nuances that evolve in language. There's different contexts, there's different groups of people that use language in different scenarios, and there's many of these examples. So we had a club that we prototyped for called Git Army, and of course when you play football, people tell you to fucking go, and that's okay to say, but if you said that in a different context with that sort of entity name, then you'd have a huge problem. So this stuff is complicated, as Leanne hinted on. We need to monitor models in production, and you can't just build a model and put it out there and assume it's just going to do what you want it to do, especially when it comes to natural language processing, because language evolves the entire time. Culture evolves. You know, one thing's cool one day and then really toxic the other day, such as soccer mom. I think Sarah Palin was called soccer mom during these elections in 1996, and when we did the women's visas Euros last year, people were printing soccer moms on their t-shirts, and everyone wanted to be a soccer mom, and it became a meme, and it was really cool. And you know, the AI didn't know that because it was trained on data that preceded that football game. So there are these problems that you face time and again in production, and yeah, so I've faced them, and I've taken various steps to try and address them as much as I could. Graph network helped. Graph networks help, especially in social media context. You have Twitter, you can use graph databases such as NetworkX or PyTorch Geometric. You can try and model relationships. You can understand, for example, that some football players get more toxic comments than others, and you try and understand why, because they're not necessarily the players that get the most comments. So you need to try and look for relationships. And when you do that, you want to try and use a relational graph convolutional network. And there are different approaches for doing this when you have multiple relations in the context of social media. A follower is different from someone you follow. So all of these relations can give you cues with regards to how toxic a message is or how likely someone is to receive a toxic message. So this is an industry, specific use case, but yeah, when you want to build a relational graph convolutional network, I would recommend that you use a diagonal structure and just focus on the nearest neighbors, because otherwise they get really large and they will fail in production, and that's expensive. So the next thing I would like to touch upon briefly is the bias in artificial intelligence, such as the person who was predicted to not appear in court. We had Amazon made a facial recognition software. It's been used nationwide in the United States. They said that they gave it to the police, but they didn't instruct them how to use it. And the people who built the software, they were very far away from the people who wrote the documentation for the software that were talking to Amazon. So this is an organizational problem. And this particular model matched 28 members of Congress to criminal mugshots, and most of them were ethnic minorities. So, this is the sort of problem that we're facing. Yeah, go on.
Is that an issue because of the rest of the 538 weren't matched to criminal mugshots?
I suppose not. I just thought I would put it there. So yeah, it's pretty sad. I mean, this one may be funny, but there's this really lovely lady called Tammy Dobbs, and she's got cerebral palsy. She can't get out of bed, can't use the bathroom, and another AI model was deployed in Arkansas and decided that she only needs 20 hours of healthcare per week. So it was cut, and then she had no one to help her, and no support, and she had to go to court. And then the court case revealed that there were mistakes in the software implementation of the algorithm, and it negatively impacted people with diabetes and cerebral palsy. So now she has her healthcare back, but she's living in constant fear that some automated system will tell her again that it needs to be cut. So yeah, some references to that case. Another case regarding bias is Professor LaTanya Sweeney, who is a professor at Harvard and director of the university's Data Privacy Lab. She Googled her name, and she found that the first few hits were all criminal background check companies, and she obviously has a black name, and I've also tried this with some of my family members. It's pretty consistent that if you're white, you get neutral apps, and if you're ads, and if you're not, you get all of these background check recommendations from Google. So there's also the compass recidivism algorithm, which has been heavily scrutinized because it was predicting which criminals will re-offend, and it also worked out pretty badly for Black people. So there is all these problems that I would like to highlight when we deploy artificial intelligence models, especially when we're trying to get to the evaluation phase and we're making confusion matrices. You may think, okay, you have this false positive or this false negative, but for whom? So a false positive for one group is different than for another group. So this happened, for example, with the compass data set. It would falsely classify, let me just get the facts right. They were nearly twice as likely to be misclassified as higher risk compared to the white counterparts, 45% versus 23%. So you should not have just one confusion matrix. You should look at the different stakeholders in your problem, the problem you're trying to solve, and then see, how does this false positive affect this person? How does this false negative affect that person? Cancer is different from recidivism, et cetera, et cetera. Become experts in your subject and try and understand all the different stakeholders, not just the investors who send you the paycheck, or the CEO, try and understand exactly how does this algorithm and its choices affect different people who are affected by your machine learning model. Tech for good, I've done this many times as well. I've worked for a lot of startups that I thought were making the world a better place. And I've also worked for IBM. It's a great company. However, in 2001, a Swiss judge ruled that it wasn't unreasonable to deduce that IBM's technical assistants facilitated the task of the Nazis in the commission of their crimes against humanity. So this is something we don't really speak about, but this here is actually the CEO of IBM sitting with Hitler, and he was awarded the Service to the Reich Medal in 1937 for their services helping the Nazis organize different races in concentration camps with their technology. And it wasn't a one-off thing that they deployed some software and sent it to them. They kept going to concentration camps to do maintenance, and this is more common than you think. So,
Hugo Boss, isn't it?
I think so,
yeah.
yeah.
The uniforms.
Yeah, yeah. So yeah, this is the card system that they made. They had different codes for gypsies and Romanis and Jewish people, and yeah, so they were very actively involved in this, but they were proud at the time of their technical achievement and the tremendous profits that this work brings. They landed a huge government contract, and they didn't see it that way. So when we learn new things and we're making breakthroughs in AI, maybe it's good to step back and wonder, how would people read this in history books like 50, 100 years from now, So yeah, Leanne touched on how to monitor AI performance in production. So I have models for, I think, automotive companies that price used cars that are still in production 8 years on and nobody's ever touched them. So I have no idea how they perform. But social media, I didn't get away with being so lazy, because people get very angry when their model, hides their post and they didn't think it was toxic, and then they challenge you. They send you very nasty messages, admin. If you are beep, 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 then hide this. And so it's kind of a big deal if you get machine learning wrong on social media. So I'm going to quote someone else here, although I totally agree with this opinion. So Elena Samuilova is the co-founder and CEO of Evidently AI, and she says, you typically do not get immediate feedback. There is no quick way to know if the predicted labels are correct. And there are few things that we can do about it, most notably the feedback mechanism. So when I did the social media content moderation, for example, we had a QA dashboard where human moderators could sample some of the posts and decide if they agreed with the AI or not, and then this can feedback into the model, and we can retrain the model based on the incorrect results. There is obviously, and ChatGPT founders know more about this than me, but there's reinforcement learning from human feedback. So you could, refine a model in that way as well. But it's an ongoing chore. You're never done training the model, especially when you're moderating text and you're talking about real people. And then there is manual labeling as quality control, so you can hire a team of people who will use unseen data, in your current context, and to see if the model still works, and then, incorporate that into your machine learning workflow. So regardless of which method you use, all of these checks are reactive. So you deploy a model out into the world, and then you need to watch it. You cannot just let it sit there, because it will degrade. And it's expensive and tiring to watch them. Now, large language models, obviously all the problems I've just highlighted are even larger. When we speak about large language models, scientists at the ISR have probably said that we don't know how to tell which sort of application is the capability of harm going to arise, either smoothly or unpredictably. But what we do know is that LLMs have hundreds of emergent abilities. They can do things such as multiplication, generating executable computer code, and classifying movies based on emojis. So all of this is pretty impressive, but it's also pretty scary. So the functionality of the model skyrockets at a certain threshold, and I've looked into this. I don't know if these figures are relevant to anyone, but since everyone's trying to train their own large language model at the moment, apparently it takes 10 days to train one and £200,000 in server costs. And if you've done data science experiments before, you know that the first model you get usually gives you a terrible score. So just imagine the figures and how they add up if you're trying to achieve something like this. It is an intellectual arms race, though, because what we're going to end up with is that the people who can afford all these server costs are going to make better and better models. But that's the place in time and where we are. So, about bias and what I think is the problem with bias. As I hinted on earlier with the vector embedding space, it's my firm belief that the bias does not come from the data set, it doesn't come from your neural network architecture, it doesn't come from your activation function, it comes from your tokenizer. So we tend to use pre-trained tokenizers, especially if you've used the transformers library before. You probably import a tokenizer, it's seen a lot of words on the internet, and then you apply it. However, that tokenizer is the part in your process where the meaning of the words gets translated into vectors. So if, for example, this tokenizer puts the word God, trying to be PC here, foreigner and criminal in the same embedding space, they're really close to each other in one of these many dimensions of matrices that you have, then you have a problem. And this is where this is coming from. So you can try all the time doing your hyperparameter tuning. You can try all the time, oh, I'm going to use sigmoid, I'm going to use this, reload. And the problem is the tokenizer, and you can build your own tokenizer from scratch, but it's a chore, just let me tell you this, but there are ways of doing it. Now, do we think that if we build larger and larger AI models, eventually we'll get this like universal, fair, godlike machine that just doesn't have bias because it's seen it all and knows it all and it's just going to give us like fair judgments? I don't know, is the short answer, but positional representations at the embedding layers, as in the transformer model, and the non-linearities and the self-attention, they do seem to indicate that AI models can be superior with regards to bias as opposed to humans, because you've got the non-linear layer when you have a simple feed-forward network that you can approximate any equation when you want to relate A and B and try and understand how these two are related. You don't depend on linear functions, and humans are very linear in their thinking. They come from one conclusion to the other, and there's always a straight line, and it's just not how it works. So because the neural network on the deepest level in all these dimensions, you've got 500 dimensions, they can approximate linear functions extremely accurately. And I think provided we give the models enough tokenizers and we accept that our tokenizers are biased because we pick the data for the tokenizers when we pre-train the tokenizer, they have the potential to be less biased than us, but we are biased because we feed it the tokenizer. So I think we need to be honest with ourselves and understand that as humans we're biased. So for example, if I want to make content moderation for football fans, I better use a tokenizer where I know, like that's trained on that sort of language, that sort of community. You got some fans that are more, left and others are more right, and you can't build one AI that serves everyone. I think you need to understand where your biases are. You need to be honest with yourself. Where am I on the political spectrum? Where am I on this and this and this camp? And then choose these models and do some sort of decision algorithm that then takes the outputs of various of models that you would obviously deploy as inference servers on a microservices architecture using Kubernetes. You kind of have to accept that you will always have bias. So the potential solution is that data scientists need to be part of a cross-disciplinary team. They need to understand the subject matter that they're working on. They cannot just learn how to build a neural network and just feed any data into it and assume that they're going to get good results. Make them subject experts and make them understand what the problem they're solving. Let them get to know the stakeholders, who are the clients, who are the investors, who are the, people who may be affected by your model and its decisions. This is really important. And utilize graph networks more. So graph neural networks are a bit under-researched and underutilized in my opinion, and I don't think there's been enough work done on linking them with large language models. So there is so much to be gained from using them, and if you use, for example, the embedding space from some large language model before you use the final activation function and then feed it as a node embedding, into a graph network and let it make connections, I think you come to better results. And it's not too expensive. You can use PyTorch geometric. There is a graph database also, which is pretty cool, which is Pinecone. You can store vectors in it. So I think that really improves our work and it will help us build better models. Other than that, meta-analysis, which is the statistical combination of results from 2 or more separate studies. I've done this extensively. Don't build one big model and think it's going to be good forever and deploy it and then let people use it 10 years down the line. Build a model, deploy it as an inference server. Then maybe 6 months down the line, you realize, okay, actually our accuracy isn't so good. Our human feedback isn't so good anymore. The model is underperforming. Or these used cars, you know what? The prices have changed. Our model doesn't predict them anymore because we gave them prices from a year ago. So what you can do in that case, instead of trying to update the model and make it bigger and bigger, and you've got trouble with version control, you've got trouble with data control, you probably have a pipeline where data flows constantly into your database. How are you going to restore this point in time where you trained that model from a year ago? So I'd recommend you use a microservice architecture to deploy different inference servers, then take the results and feed the result of the inference service into another decision algorithm or another neural network. And then that way you have version control of your models that you've deployed, but you're not static. You can evolve them without actually losing the initial model and the initial data that it was trained on. So that is everything, really. So thank you very much.